In this lab video, I'm going to go over some sample calculations for experiment number 7. What I've done over here on the right, I made up some sample data just with numbers that will be easy to use as examples. You'll need to use your student data set from Canvas. Make sure to use your student data number that was assigned during experiment number 1. The first question asks you to write 2 chemical reactions that the copper chloride hydrate is undergoing. I'm not going to write these for you, but I'm going to give you a couple hints. So the first chemical reaction we saw during the heating. So during the heating, we took our copper chloride hydrate, and remember, if you heat it, an ionic compound will stay the same, but the water will evaporate. Think about that. You also wrote that reaction with the copper sulfate pentahydrate in our experiment number 6 post-lab. The second reaction was when we performed a single displacement reaction. Between our copper chloride hydrate, or copper chloride, excuse me, it was aqueous at that point, and the aluminum wire we added. So go ahead and write the single displacement reaction, and those are the reactants. Question 2 asks you to calculate the moles of water in your sample. We have to think about our data to figure out what numbers to subtract. What we have here the sample data, so we have the empty test tube, right? So just our test tube. We have the test tube with the sample, and this is the sample before heating. So that sample is your CuXCly.ZH2O. So that's the compound with the water. After the heating, so it's our test tube and the sample after heating, that means it's just the CuXCly solid. The water has been evaporated. So to figure out the mass of just the water, we take our test tube and sample before heating minus the test tube and sample after heating. So in this case, with my sample numbers, 12.000 grams minus 11.500 grams, keeping track of significant figures, so subtraction, we need digits past the decimal, 0.500 grams of water. And then the question asks us to find moles of water, so we're going to convert to moles of water using molar mass. To do that, 0.500 grams H2O. So I need units of grams downstairs to cancel, moles upstairs, which are our target units. I know that 1 mole. Now you need to figure out the molar mass of water from the periodic table. So you add up the mass of 2 H's and 1 O, keeping track of sig figs. When you do that math on your calculator with your numbers, your units of grams cancel, and we're going to end up with moles of H2O. So that'll give you a start with number 2. Question 3 is asking, after you have the mass of dried copper, which we have because we have all of our sample data numbers, calculate the number of moles of copper and the moles of chlorine in your sample. So to get the moles of copper, we need to first get the grams of copper, or the mass of copper. Looking at our sample data set, so we have the clean filter paper as 1 gram, mass of dry copper, solid, and filter paper is 1.2 grams. So you can see if we have just the filter paper and then the filter paper with the copper, if we subtract the filter paper plus the copper minus the filter paper, we will end up with just the mass of copper. So the numbers that we're going to use to do that then. So my sample data set, you'll use your specific numbers from Canvas. Again, keeping track of sig figs, so 0.200 grams of copper. And we're going to convert to moles of copper using molar mass from the periodic table as a conversion. So just like we did for water, but for copper. And that will then give us moles of copper. Looking at these numbers, we have the grams of water, we have the grams of copper. We need to figure out the grams of chlorine. So to get the grams of chlorine, or the mass of chloride, I need to subtract. So I have to take the mass of my entire compound, CuXCly.ZH2O, subtract the mass of the copper, subtract the mass of the water, and that will give us the mass of the chlorine. To do that, so remember we have our grams of water right here, so that goes right here. We have our grams of copper right here. Now we need to get the mass of our copper chloride hydrate. Well, with my sample data set, I have the mass of just the empty test tube, and I have the mass of the test tube plus the entire sample. So to get the mass of the CuXCly.ZH2O, I'm going to subtract the mass of the test tube with the sample, which with my sample number is 12.000 grams, minus the mass of the empty test tube. And again, you'll use your specific numbers, H2O. And so that number will go here. So you can subtract to get the mass of chlorine, and then you'll convert from grams of chlorine to moles of chlorine using the periodic table. Now that you have all of the moles, so that's our answer to number 3, question 4, determine the mole ratio of copper, chlorine, and water by dividing the smallest number. So just like I showed in my practice or in the video for the pre-lab calculation, so we have our moles of water, moles of copper, moles of chlorine, whichever is the smallest number, divide all of those by the smallest number. So you will end up with one of those moles will be 1, because the number divided by itself is 1. And then the other two, you're going to get hopefully close to a whole number. Remember your significant figures. And then lastly, 5, you'll convert those whole numbers into a chemical formula. And so we'll have Cu, instead of X, you'll have a number. So there'll be a number here, Cl number dot Z, so a number there, H2O. And that would be your answer to number 5. For the post labs, the results table, a summary of results table, great items to include in your results table: the mass obtained of your entire sample, the mass of copper obtained, the mass of water, the mass of chlorine, and then lastly, your entire chemical formula. Next, you'll write a well-written conclusion, so this should be incomplete paragraph. You want to analyze the results. So this means you need to write a couple well-written sentences discussing what you did and the results that you obtained, and also analyze the errors. So this should be a really well-written paragraph in complete sentences. I hope this recording helped with your post lab. If you have additional questions, please go ahead and post them in the discussion forum for experiment number 7.